Hello, everybody. So, this is the day I had a workshop in Jaipur, and now I think this is around 7:30, and we are traveling back to Muzaffarnagar from Jaipur, and this peripheral highway, newly built highway. So today, actually, I had a very interesting discussion with the teachers there. Uh, the teachers were saying, yes, activities and this practical approach is good, but then it is not very apt for the classes, for higher classes. So I was really puzzled with the way they were thinking about this practical approach. Actually, what is practical approach, and is there something which is not practical at all in mathematics? I think it's hard to believe that mathematics isn't practical. So, like, I think why I'm shooting this video, you see, there are many vehicles on the road and just running, and let me tell you, the speed limit for the cars on this road is 100, and for larger, heavier vehicles is 80. Wow, some bumps are there. I was thinking, what is practical approach? Actually, I just um, maybe I think we can just assume, or just leave this practical. What is realistic and what is idealistic? And the most of the time, so what we as teachers are doing, we are simply solving the questions and not the problems. And those are idealistic, very ideal questions given in the textbooks. So we are highly, or maybe overly dependent on the textbook. See, I think there is a truck. There's a truck ahead of us, and now my car, and the speed of the car is around 74, 75 kilometers per hour, and now we are going to pass this one, and now we have passed this truck. So what can we deduce from there? Rico, see, a whole lot of mathematics we can think of doing here in this situation. Okay, so that truck was at certain speed, and our car is at a speed. So obviously, the speed of the car is higher than that of truck. And at the same time, did you notice that I think that much distance that was there, we covered the distance in 3 seconds or 4 seconds. Okay, so what could be? Can we just see that if the distance we covered in 3 or 4 seconds, so can we say something about the speed of the truck? Well, it's really a very realistic mathematics that we can do here. Now there are two vehicles ahead of us, and one vehicle is trying to pass another vehicle, and now we will pass both of these people. I'm sure both of these vehicles we are passing now. Can we deduce something from this situation? Actually, right from the problems related to speed, distance, and time, we can think of the problems, involving maxima and minima, and we can think of the problems involving derivative. Wherever there is a movement, there is derivative. And today, one grade 12 teacher was saying that derivatives and then the integration, these are very abstract concepts, and we can't just show them practically in the classroom. So I was really, really, really worried with this approach. So I think, guys, this is the road, and everywhere the mathematics is around you. Just you should be aware of that and do that. All the best. See you in the next video. So the whole point is whether we are doing mathematics that is real, that we can see in real life, or we are doing mathematics just using the mundane routines of the textbook and the textbookish knowledge. Actually, teachers what means, their argument is they have to finish the syllabus. The thing is, when they finish the syllabus, they finish the child also, because they finish the child means not the child, actually the child's curiosity, the student's excitement to learn mathematics. In fact, the video that I was showing you of those vehicles, for example, like, this very real, this very realistic, like, come here, like on my table there are some vehicles, and I'm just trying to do this for you. Like, these two vehicles are moving at a certain speed, and
Just to make it a little more interesting, let us see that these two vehicles are moving at the same speed, constant. So their distance remains constant at any given time, and at that very moment, some other vehicle is trying to pass these two cars. You know, now imagine this whole situation, try to visualize it. This much distance, this distance is constant but moving with the time. This distance is moving, and this truck is trying to cross, or maybe like cover this distance, pass these two vehicles. So the thing is, what would be the kind of connections between the speeds of these two cars and this truck? Isn't it very interesting? And the whole concept of derivative, like how fast is the truck's location, or the distance between the truck of or any of these two vehicles is changing. How fast is it changing or decreasing the space between these two vehicles or these two vehicles? So these things are very important, and such kind of experiences we should give to the students. Otherwise, they will remain wondering what to do. Somebody should tell them how to do. Somebody should tell them the formula. you know they should be given opportunity to formulate, to decide which formula to use, to conceptualize the whole thing, and to find out something as a tool to solve a problem that is given, and that becomes a mathematical concept, and then the real learning happens. Otherwise, we will keep on reproducing the knowledge which is already there in the textbooks, and that knowledge is just good for writing the answers in the exams, and not